Hi guys, salamat sa inyong patuloy na ginagawang pagsubaybay dito sa ating discussions about fluid mechanics and hydraulics. At ang ating magiging topic ngayon guys ay ito namang tinatawag nating Boyle's Law. At sa pamamagitan itong video na ito ay lalo nating maintindihan kung paano siya gamitin sa pag-solve ng problems in hydraulics. So meron akong inihandang tatlong problem guys para lalo nating maintindihan kung paano siya i-apply, no? At subaybayan natin na ito yung ating first problem. Sabi dito sa first problem ay, assuming normal barometric pressure, how deep is the ocean at a point where the volume of an air bubble at the bottom will be multiplied by 15 upon reaching the surface. We are being asked here, how deep is this ocean? Okay, when a bubble that is produced will become 15 times greater than its volume when it reaches the surface. So, kumbaga, uh, nung nasa ilalim pa siya, assuming that the volume of the bubble is V. So, we will be expecting that at the bottom, there will be an absolute pressure, okay, which is equal to 101.3 kilopascal plus the pressure exerted, okay, by the fluid having a depth equal to height and a specific gravity of 1.03. So lalabas ang kanyang absolute pressure at the bottom will be 101.3 plus WH. So when it reaches the top of the ocean or at the surface, okay, the bubble will increase its volume. Diba? Kumbaga, ang volume niya ay magiging ganito. So, habang tumataas siya, okay, lumalaki siya until it reaches the top na kung saan ang kanyang volume at the surface ang kanyang volume ay yung kanyang volume will be equal to 15 times the volume at the bottom. And because it is already at the surface, okay, when it reaches the surface, yung kanyang pressure ay nagiging okay, atmospheric pressure na lamang. That is 101.3. Kaya ipapakita natin dito guys, so how are we going to solve for the problem? So kung titira natin dito, if we're going to apply, okay, the Boyle's law, which says that, okay, the product of the pressure and the volume is constant. So that P1V1 is equal to P2V2. So in this case, we are going to consider the initial condition at the surface. Ba? So we shall be using here, okay, that 101.3 being the pressure and the volume being equal to 15 times the volume at the bottom shall be equal to the pressure at the bottom, which is 101.3 plus WH, di ba? This becomes 101.3 plus WH multiplied by V, where V is the volume of the bubble at the bottom. So when we simplify this, okay, you will have a W. By the way, the W, the unit weight of the liquid will be equal to 1.03 multiplied by 9.81 being the specific gravity of the water multiplied by the sea water or the ocean multiplied by the unit weight of the water. And so when we simplify this, substitute this W here in this particular equation, then we shall be getting, okay, 101.3 multiplied by 15V equal to, okay, 101.3 kilopascal plus 10.01043 height multiplied by the volume. So in this case, yung volume will cancel each other. And so leaving us an equation, okay, having H as the only unknown na kapag ating sinubstitute itong H neto, therefore our H will become equal to 140.36 meter. Meaning, itong height ng ating depth, ng ating ocean is 140.36 meters. So, ganun lang kasimple yung ating application. So, subukan natin itong second problem which I have prepared. So, the second problem is a cylindrical tank having a diameter of 100 millimeter and a height of 5 meters is open at one end and closed at the other end. It is placed below the water surface with closed end uppermost. Yun daw kanyang closed end nasa ibabaw. How deep below the water surface? should the tank be placed if the water inside the tank is 2 meters? So, kumbaga, okay, kung i-illustrate natin yan, no, imagine natin na ito naman yung ating tubig, ating water. And initially, meron tayo ditong unit weight of the water of 9.81. But dito sa given na sinasabi na cylindrical tank having a diameter of 100 millimeter and a height of 5 meters. So ito yung ating, imagine natin ito yung ating cylinder na kung saan ang kanyang diameter is 100 millimeter at ang kanyang height ay 5 meters. Di ba? So, we are asked here how deep below the water surface should the tank be placed if the water inside the tank is 2 meters. Gano'n daw siya kalalim. Di ba? So, pwede nating pagbasihan yung lalim, i-measure natin mula sa pinakataas ng ating um, cylinder when it's already submerged in water. And we understand na habang ito inilulubog natin, yung tubig ay papasok sa ating cylinder until such time that the water inside the cylinder is already 2 meters. Kaya i-animate natin, ipakita natin na kunwari ito ay ating inilubog. Okay? So nilubog natin dahan-dahan, makita natin na pumapasok kayo yung tubig sa loob. Di ba? Ito. Na kung saan nung ang kanyang tubig is already 2 meters, okay? Sa makatwid itong height na ito, ang tinatanong natin. Yung depth of water above, okay, the cylindrical. So let us imagine that this is our y. Therefore, this y can be taken if we consider this as 3. So yung depth of water mula dito, okay, assuming natin itong height na ito ay h, di ba? Therefore, yung height y natin dito will be equal to the difference between h and 3. So our y will be equal to h minus 3. Ano? So if we will be applying here the concept of the Boyle's law, so we let this y be the distance from the water surface to the upper end of the tank. Ito daw y na ito mula distance mula sa surface nito hanggang dito sa upper end ng tank. So apply natin ng Boyle's law na sinasabi P1V1 is equal to P2V2. So kinakailangan ma-identify natin ano ba yung condition of the cylinder at the first initial or the initial condition. So initial condition natin dito okay, is when the cylinder is not yet submerged in water. So because the cylinder is exposed to atmosphere, we will expect therefore that okay, the initial pressure will be atmospheric pressure. And this atmospheric pressure has a value equal to 101.3 kilopascal. And initially, the volume of the air or V1 is the volume of the cylinder itself. And because the volume of the cylinder is equal to area of the base multiplied by the height, where the area of the base is in the form of a circle whose diameter is equal to 0.1 meter, then the volume will be equal to pi over 4 times 0.1 square multiplied by 5. So when okay, we consider the condition such that the cylinder is already submerged in the water, ano? So ipakita naman natin yung condition na kung saan it's already submerged in the water. Then for we will expect that the P2 or the pressure of the air is the pressure at the point okay here, di ba? Ito yung pressure dito. And the pressure here will be equal to the sum or the absolute pressure at this point, which is the sum of the atmospheric pressure multiplied by okay, the unit weight multiplied by the height. And so this pressure sub 2 will be equal to the atmospheric pressure plus WH, which is equal to 101.3 kilopascal plus 9.81 H. And our volume here will be equal to the volume of the air that is remained inside the cylinder. It is actually this volume of the air. Okay, yung V sub 2 na, okay, yung air na tira, okay, pagkatapos na pumasok na yung tubig dito. Which has a height therefore of 3 meters considering that it is a cylinder, ano, with the same area or area of the circle and a height equal to 3. So if we will be substituting it here, the volume will be equal to pi over 4 times 0.1 square multiplied by 3. And if these values will be substituted in our equation for okay, P1B1 equal to P2B2, di ba? So kunin natin yung lahat ng value na yan. So we will have okay, this value. That 101.3 kilopascal is equal to pi over 4 times zero point 0.1 times zero point 0.1 squared times 5 will be equal to the quantity 101.3 plus 9.81 H. Okay, multiplied by pi over 4 times zero point 0.1 square multiplied by 3. So from there, makita natin yung pi over 4 will cancel there, ano? Okay, and the zero point 0.1 square will cancel, leaving us, okay, an equation which has an unknown equal to h. So that if h will be solved, simplified, so we can compute for the value of h equal to 6.88 meters. So after we have solved for this h, take note that this h is the height of the water up to this level, the depth of water up to that level. But if we will be looking for the value of y, or the depth of water from the water surface to the top of the cylinder, therefore we have to consider, okay, subtracting, okay, this height of the air inside for the value of h. So therefore, ang ating y will be equal to h minus 3. And that the depth of the water will be 6.88 minus 3, giving us a value of 3.88. So this 3.88 therefore is this height, okay, of the location of the top of the cylinder below the water surface. Ito yung value ng y. Nakikita natin, 3.88 meters. Ah, now, puntahan naman natin itong pangatlong problem. Sa pangatlong problem, we have here a tank in the form of a right circular cone. Circular cone naman ito is open at the base. It has a diameter of 2 meters and a height of 3 meters. It is submerged in water with the vertex uppermost. Okay, yung vertex ng cone is uppermost. The question is how deep is the vertex below the water surface such that the water inside is half of its volume. Take note, ano, yung sinasabi dito that the water inside is half of its volume. So yun yung condition na kapag inilubog na siya, okay, may napasok na siya ng tubig na kalahati ng volume ng right circular cone. Para mas madali natin uling maunawaan, siguro illustrate ulit natin. So meron ulit tayo ditong liquid. On here ay meron tayong right circular cone na mayroong dimension, ano? A diameter of 2 meters and a height of 3 meters. So ipakita natin dito yung kanyang, okay, right circular cone. Ito yung kanyang diameter. Open siya at the base, having a diameter of 2 meters and a height equal to 3 meters. So ilulubog ngayon ito, sabi dito, it is, okay, submerged with the vertex uppermost. So ito yung vertex, nasa ibabaw lang, nasa itaas siya, ano? How deep is the vertex below the water surface such that the water inside is half of its volume? So ipakita natin ito na inilubog natin dahan-dahan. Okay, ano mangyayari? Unti-unti pumasok yung tubig, di ba? So yung tubig daw na nasa loob na nung ito inilubog na, sabi dito, this volume, okay, is already equal to one half of the, okay, cone. So ang ipinapahanap sa atin is this height mula sa apex hanggang sa liquid surface. So this is, okay, the depth of the liquid that is being asked. And so we expect also that this volume of the air will be equal to the volume of the water. And that is also equal to one half of the volume of the cylinder. So, i-apply natin dito ngayon yung ating Boyle's law, no? Sabi dito, P1V1 is equal to P2V2. Ang kinakailangan lamang natin ma-define kay yung initial absolute pressure, initial volume, kay the final pressure, and the final volume. So, let us try to imagine the initial condition when the cone is not yet submerged in the water. Ano? Nasa ibabaw pa lang siya. Ipakita natin muli, ito yung kanyang, okay, condition. Sabi dito, it's open at the base, therefore this base is open, hence we expect that the pressure, ano, the absolute pressure of the air inside is atmospheric, hence P1, okay, will be equal to atmospheric pressure, and that will have a value equal to 101.3. And the volume of B sub 1 is actually the volume of the cone. Since the cone has a uh, an area which is equal to actually area, one-third area of the base multiplied by the height, ano, or one-third of the volume of the circumscribing, okay, cylinder. Where, okay, the circumscribing cylinder has a volume equal to area of the base multiplied by the height. So, balikan natin ang dimension nitong ating cone is in the form of a circle, ano, ng kung saan ang diameter nito is okay, 2 meters, or simply the radius equal to 1. Meron siyang height na 3 meters. And from this dimension, makukuha natin ngayon yung V1, ano, which is equal to 1/3 multiplied by 1 multiplied by pi multiplied by 1 square multiplied by the height. So when we simplify this, we shall be getting the volume equal to pi. Yun yung initial volume of the cylinder. Now, considering the second condition, when the cone is already submerged in the water, nasa ilalim na siya, ipakita ulit natin yung condition na yan. Ito yung condition. Kaya ang ipinapahalam ko sa atin dito itong depth, ano? But at this condition, the volume of air inside is already 1/2 of the volume ng cylinder. And the pressure is the absolute pressure at point 2, yung point dito, no? Yan sa point na yon. Kung ito yung point 2 natin, then the pressure at that point is what we are actually looking. Assuming natin that this is at height, okay, at h from the apex. Di ba? Sa mga katuwid, yung absolute pressure dito will be the atmospheric pressure plus the pressure due to the liquid, which is equal to W multiplied by the sum of D and H. Di ba? Kaya kung ito simplify natin dito, it is the atmospheric pressure plus W plus, multiplied by D plus H. Okay? But, itong height ay makukuha natin ito kasi nabanggit na dito na itong ating volume ng air is 1/2 of the volume of the cone na na-compute na natin that is equal to 1/2 of pi. Di ba? So, kumbaga, itong smaller volume of the cone, the radius of the base, kung pakita natin itong volume ng cone ito, no? This cone would have a radius equal to r and a height equal to h, di ba? Altitude equal to h. And that the volume, of that cone will be equal to 1/3 of the circumscribing cylinder. That is equal to pi times r squared multiplied by h. And that it is equal to pi over 2. Kaya kapag ito sinimplify natin yan, yung pi will cancel at makakakuha tayo ng relationship between r and h, and that is 1/3 of r squared multiplied by h is equal to 1/2. Okay? But there is a relationship between R and H, di ba? Okay, meron tayong makita relationship between R and H dito. And that the relationship can be taken by duration proportion. Okay, that this smaller triangle is proportional to the larger triangle, ano, by duration proportion. At makikita natin dito, okay, itong triangle na malaki, mayroong radius na 1 at may height naman na equal sa 3, given yan. So, using the ratio proportion, masabi natin that the ratio of R to the H representing the radius of the smaller to the height of the smaller is proportional to the radius of the larger, which is 1/3 or to the height of the larger. So from here, masosolve natin yung R which is equal to H over 3. And that if this H over 3 will be substituted here in R square. So therefore, we shall be getting that 1/3 of H over 3 square multiplied by H is equal to 1/2. And then simplifying, solving for H, masosolve natin yung H na 2.38. Now, after we have solved for 2.38, so makukumpita natin ngayon yung atmospheric pressure expressed in terms of the depth D. Di ba? So, if you are going to substitute the values in the formula for the Boyle's law, that P1B1 is equal to P2B2, let us substitute it one by one. Ano? Our P1 here, our P1 is actually the atmospheric pressure, ano? Okay, before the cone is submerged in water, which is equal to 101.3. Let's just write it here. And our B1 is the volume of the cone and is computed at pi. So that is equal to pi. Our P2 is actually the pressure at this point 2, which is shown before as the sum of atmospheric pressure, plus the pressure due to the water, which is equal to the product of W multiplied by D plus H. But H is computed at 2.38, so we write it here at 101.3 plus W multiplied by the quantity D plus 2.38. So if this will be multiplied by V sub 2, which is computed to be the volume of the air here, and is computed to be 1/2 of pi, kasi kalahati na lamang ng cone ay napasok ng tubig. Therefore, kalahati ng cone ay air pa rin. So this is equal to half of pi or 1/2 of pi. So from here, yung we can solve for the value of D, no? Okay, that okay, D will be equal to 11.7 meters. Okay, so ibig sabihin, the depth of the water from the uh, apex of the cone to the liquid surface must be 11.7 meters before the water inside is already one half of the volume of the cone. Kaya yan guys yung ating mga sample problem na ipinakita kay about Boyle's law, no. Sana sa pamamagitan ng mga simpleng problem na ipinakita ko sa inyo ay lalo ninyong naintindihan kung paano gamitin itong tinatawag nating konsepto ng Boyle's law. Once again guys, inimbitahan ko kayo na sana ay subaybayan niyo ako sa ating ginagawang mga discussion by subscribing to this channel. And if you have friends that will need this kind of lecture, okay, please share it to them so that they will also be informed and uh, notified of these lectures. Thank you very much for watching.